And I'll do another example of Maclaurin series for you. So this time we're going to try and do the Maclaurin series for the natural log of 1 plus x, and we want to find the first 4 terms, which means we have to keep on going until we get 4 non-zero derivatives. Okay, so basically it's just the same as the previous effort. F of x is the natural log of 1 plus x, and we've got to evaluate each of our points at 0, so the function evaluated at 0 is the natural log of 1, which is 0. Okay, so that one's not going to count, unfortunately, because we're not going to get a term from that. It's just going to go to 0. So we need 4 non-zero terms. So we need to carry on. So the first derivative, well, when you differentiate a log, you get 1 over times 1 in this case. It's not going to change it. And I'll just, to make it easier for the next step, let's write that as 1 plus x to the power of negative 1. And then we want to evaluate that at 0, so we're going to get 1 plus 0 is 0, 1 plus 0 is 1, I'm on fire today, 1 over 1 is 1. Second derivative, so that one's going to count, because it's not 0, so we've actually got one term, which is sweet. Derivative of this thing, so channel, so negative 1 plus x to the power of negative 2 times 1, doesn't change it. So the second derivative of 0, sticking 0 into here, 1 plus 0 is 1. This time I'm onto it. 1 over 1 squared is still 1, times negative is negative 1. The third derivative is going to connect down the front. 2, 1 plus x to the negative 3. So the third derivative evaluated at 0. This thing's always going to go to 1. So it's just equal to 2. So I've now got 3 terms that I can use. And the fourth derivative of x is going to be negative 6. 1 plus x to negative 4. So the fourth derivative evaluated at 0 is going to be negative 6. So I now have 4 terms that I can use. So I can stick it all into Maclaurin series, which tells me that f of x equals f of 0, which in this case is 0, so that one's not going to count, but it doesn't matter, plus x lots of the first derivative, plus x squared over 2 lots of the second derivative, plus x cubed over 3 factorial lots of the third derivative, plus x to the power of 4 over 4 factorial lots of the fourth derivative, plus any other terms we've got, which we don't have in this case. So what have we got? We've got 1 times x is x. It's going to be a minus x squared over 2 plus x cubed over 3 minus x to the power of 4 over 4, and I bet you could guess what's coming next. This is one that is nice and simple to work out what the continuing pattern is, and that's often the case. Once you've done a few, you can see what the pattern is going to be. So let's just try and see how well this one's worked out. So we'll let x equal 0.1, and then we'll try evaluating the two things. So natural log of 1 plus x is the natural log of 1.1, which equals natural log of 1.1, 0.0953. 0.0953. And using the expansion that we've come up with, so our Maclaurin series expansion, we're going to end up with f of 0.1 equals 0.1 minus 0.1 squared over 2 plus 0.1 cubed over 3 minus 0.1 squared, to the power of 4 over 4. And if we work that out, calculator, we have 0.1 minus 0.1 squared over 2 plus 0.1 cubed over 3 plus 0.1 to the power of 4 over 4 equals 0.0954, which is pretty good. So this 4-term Maclaurin series for natural log comes out very well for this value. It is needs to be pointed out that the closer the thing you're trying it for is to 0, because of all these zeros, the better it is. If you've got a point which is well away from 0, then you really want to try using the Taylor series. The Maclaurin series is a special case of the Taylor series, a special case in that it works close to 0. But there's a thing called a Taylor series which enables you to move away from 0 if you need to.